Hello and welcome to review of trig graphs. So this is directly from the review sheet. Hopefully it helps you if you need help for the test on Wednesday. Okay, so it's all on the trig graphs. The actual review part of the test you have to do on your own. Okay, so here we go. When you're writing an equation, and remember we're writing an equation of each of the following graphs, we're going to have no horizontal shifts. That's a shift. Okay, so that just means that we're going to have an A, a B, and a D. Okay, remember the horizontal shift is our C, not our cycles, but our C in the equation y equals A. And in this case, hopefully you realize this one is going to be sine B, I'm running out of space, x plus C plus D. Okay, that's blatantly obvious now, but here we go. So to find these things, you have to know what each one relates to. So remember, A relates to the amplitude. D is the midline. I generally say find D first because that's going to tell you first if it's sine or cosine, and then it's going to tell you the amplitude right from there. So the midline is right here. If you're not sure, remember the formula for amplitude is the max minus the min divided by 2. And it's technically the absolute value, but that shouldn't be a problem in general. And remember that that's the amplitude. And the midline's formula is the max plus the min divided by 2. So if you're not really sure, you can't tell where the midline is, but you see that the highest part of the graph is 5, the lowest part of the graph is 1, you can just plug them into these fancy formulas. Okay, but hopefully you can see it. And here the max is, at the midline here is 3. The amplitude, we start at 3 and we count up 1, 2. Okay, and then from this we should be able to decide that it's sine, because remember sine starts at the midline. So sine starts at the midline. So this is the midline. Sine is starting right there. Done. Okay, the last thing we have to find is the B. Okay, for B, you have to remember B is your cycles, and it's the number of times the graph repeats between 0 and 2 pi. The number of times the graph repeats between 0 and 2 pi. So if you look at this guy, this is 0. Right here is 2 pi. So how much of the graph happened? Well, a half of the graph happened. There we go. So the equation, we just plug in A, B, and D. We don't need the C. This has gotten a little messy. So the equation is y or f of x, however you want to do it. Y equals 2 sine 1/2 x plus 3. Okay, remember the only time this 2 is negative is if this graph started and went down. Started at the midline and went down. That would constitute a negative. It doesn't, so it's positive. Done. All right, I'll do the other ones faster, but I just wanted to make sure you understood those pieces. All right, here we go. Find the equation. I don't like that color. So A, B, and D. Those are the only 3 we need here. So looking at this, I like to, again, find the midline first. If you're not sure, max plus min divided by 2. There's the midline. Start here and go up. 1, 2. So the midline is 3. The amplitude is starting at the midline. Count 1, 2. Okay, so from here I can decide if it's sine or cosine. So this is the midline, this is the y-axis, and that's where we look to start. It does not start at the midline, it starts low. Since it starts low or high, that would be cosine. Okay, when cosine starts high or low, so it starts at the max or the min. Okay, if it starts at the max, then A is positive. If it starts at the min, then A is negative. So it starts low, that's the min, A is negative. Okay. B, how many times does a graph repeat between 0 and 2 pi? Well, here's 2 pi, here's 0. I only went up. To be totally cosine, I'd have to go back down again. So it's only half the graph. We're not going to do it so that you have to do like 3/4 of a graph. Not like this. Okay, so then we simply plug it in. We remember it's cosine. So y equals -2 cosine 1/2 x plus 3. There we go. Done. All right, this one. Again, try these on your own. Just watching me doesn't really do much for you. So try them on your own and then come back if you have a problem. Otherwise, just check your answers. Okay, the keys should be online too. So A, B, and D. Again, the midline. Okay, if it goes down -2, up -2, the midline is going to be right at 0. So there is no, there's no shift. A, you start at the midline, go up 2. You have to start at the midline and find the max. That's 2. Now B is how many times the graph repeats between 0 and 2 pi. But looking at this, I don't see 2 pi. It's not there. So what you have to do is you have to use your period, just like we did in writing the equations given the information. So remember, the period is how long it takes to make one complete cycle. I'm writing with my finger. I'm not using a stylus anymore, so I don't know how this is turning out. So that is the definition of period. And remember, the formula for period is 2 pi over b. So these two things combined should help you do this. So cosine, well, I'm deciding that this is cosine because this is the midline. It starts low. So not only does that tell me that this, since it starts low, that should be negative. But since it starts low, it's cosine. So remember, if it starts low, cosine goes up, and then one complete cycle would meet you back down again. So one complete cycle took pi over 3. So that's the period. Period is pi over 3, so you set that equal to the formula, cross multiply, and solve. So pi b equals 6 pi, divide by pi, and b is 6. So between 0 and 2 pi, this graph repeats 6 times. So if we continued until we got to 2 pi, it would be 1, 2, 3, 4, 5, 6. Whoa, let's undo that, but you get the idea. Okay, so b is 6. So then we just write the equation. Again, we decided it was cosine. So the equation is, and let's switch it up a little, and you can use f of x also. I know Mrs. Infini does like the f of x, and we should probably focus on that more. So -2 cosine of 6x plus 0, but I don't have to put plus 0. So that's it. This one right here, A, B, D. Those are equal signs, not z's. All right. So what we do is find our midline. Again, you can't really tell where the midline is. You got your max, you got your min, use your formula. There's the midline. So the midline is at 1. From here going up, the amplitude is 2. So this is my graph here. The graph starts at the maximum. So this is going to be cosine. And the 2 is positive. Okay, if it started at the min, the 2 would be negative. Last thing we got to do is find how many times the b, the cycles, how many times the graph repeats between 0 and 2 pi. Same problem here. I don't see a 2 pi, and it's not blatantly obvious where it is. So the graph, how long it takes to make one complete cycle, or the period, is pi over 2, because it starts high, ends high. One cycle, pi over 2. Cross multiply, I get 4 pi equals pi b, divide by pi, and b is 4. So just plug it in, y equals 2, cosine 4x plus 1. Too easy. Okay, same questions, but without a graph. So if you have to, you can always draw a graph if that's the easier thing for you. It tells you the max and min and the period. The period might be a little bit harder for you to sketch, but you can. So the basics here, same thing. We want to write an equation in terms of sine, where we have a max, a min, and a period. And hopefully you're discovering that's all you need. If you can find a max, a min, and a period, you can write any equation. Almost any equation. Okay? Ones with horizontal shifts. I'm way too specific. Anyway, so remember, the formula for A, or the amplitude, is the max minus the min. I'm just going to do the work over here and put the answers here, okay? So it's the max minus the min divided by 2. So that's 6 over 2, which is 3. Doesn't say anything about reflection in the x-axis, so it stays positive. Okay, I'm going to do D next. Just do it right here. Because they're both related to the max and the min, it makes it a little bit easier to see. So it's the max plus the min divided by 2. So negative 2 over 2, or negative 1. Finally, the B is the one that's related to the period. You simply take the period, set it equal to 2 pi over b, cross multiply and solve. So when I cross multiply here, I get 4 pi equals b. Done. I don't even have to move it there. 4 pi. So they said in terms of sine, so it's y equals. Make sure you have that y equals or f of x equals, or it's not an equation. And if they ask you to write an equation, you need the equals. So 3 sine 4 pi plus, minus 1. Okay, again, try the other ones. They're all the same thing. They give you a max, a min, and a period. You have to just do the same things over and over. It helps you if you do it. Okay, remember, math is the sport of the mind. You got to practice. Here we go again. A, B, D. A's work, max minus min divided by 2. I'm doing D next. Max plus min divided by 2. That's handy. They're the same thing. The period is 2 pi. So remember when we're doing B here. So B is 2 pi over 1. We set that equal to 2 pi over B. Hopefully you can see the 2 pi's are equal, so this has to be 1. Or you can cross multiply and solve, and you'll get it. This one they said in terms of cosine, so y equals A cosine bx plus d. This 1 is unnecessary. Just like that is fine. Okay, 2 more. So A, B, and D again. Oh no. All right, so A, max. Okay, that's A. And then it's max minus min divided by 2. So that's 10 over 2 or 5. D, max plus min divided by 2, which is 8 over 2, or 4. And then b, we just do 1/5 equals 2 pi over b. Cross multiply, so b equals 10 pi. So let's put these in. 5, 4, 10 pi. They said in terms of cosine, so y equals a cosine b x plus d. Good. Last one here for this one. Same thing though. So if you can find the max, the min, and the period, you can write an equation. Okay, so just remember that. Max minus the min divided by 2. So that is 6 over 2, or 3. D, max plus min over 2, so that's negative 10 over 2, or negative 5. And then the b, 12 over 1 equals 2 pi over b. Cross multiply, and I get 12b equals 2 pi, divide by 12, and you get, reduce here, that's a 12. You reduce, 2 goes into 2 once, into 12 6 times, so it's pi over 6. So putting these things in, a is 3, d was negative 5, and b is pi over 6. So then when we write the equation, just checking that I'm right, I'm going to write different color. Y equals 3, they said sine, 3 sine pi over 6 x minus 5. Good. Okay, looking at the equation, can we find the range? So if you remember, the range is just simply of any sine or cosine function, it's the max, or sorry, the min always goes first, and then the max. Okay, square brackets for using your interval notation because it reaches those points, and that's the range. So if I could just find my max and my min, we're good. Now you could graph these, but I don't know, you don't have to. So if we look here, the two things that affect the range are the A and the D. They're the only two things that affect range because they're the vertical movement. The A stretches it. So remember, if we have a sine curve, the regular sine curve would look like this. If we multiply it, the amplitude gets bigger. Okay, so it stretches it. So this would be 3 and negative 3. And then this 1 here, this 1 would take it and shift it up so that the midline, instead of being here, is here. So then that would shift it up a little. And then the max would probably be at 4. Not probably. It would be. I don't know what just happened there. Would be 4. I don't know what's happening. There we go. And negative 2. So that's, you can look at it as a graph if you didn't really grasp that. The basic idea is the max is 3. I guess this was a negative function, so it probably should have gone down first, but that doesn't change anything that actually happened. It simply just changes the way the graph looks. But the max is still a 3 to start. And the min is still a negative 3. And then you take the plus 1 and you add it on to both of them. So 3 plus 1 is 4. Negative 3 plus 1 is negative 2. That was confusing. Let's try it again. So it's simply, you just take the max and the min, okay, and you look at this number. You make it positive for the max, negative for the min, and simply add this number on. So I'm going to add a negative 3, or in this case, subtract 3 from both. So the max is negative 1, the min is negative 5. I forgot to write them like this. So for this particular one, I'm going to write it in purple. So for this particular one, in this huge mess I have, Remember, square brackets. We got max and min. Min goes first because we got to go low to high. Max goes second. So this one, you got our max and our min. Min goes first, then max. Okay, make sure you try the rest of them and then check your answers. Alrighty. Should I stay in purple? Here we go. So max and min. Quickly, this is negative, but the max is the positive, the min is the negative. Then you add the d. Only two things that affect the range. So this is 8, this is 0, so the range is 0 to 8. Same deal here. The max starts at 7. Always this number. The min starts at -7, and then we just do that. So it would be 2 to -12. Well, you know what I mean. So then the min goes first, and the 2 goes second. Done. Awesome. Okay, as the angle increases, as angle theta increases from pi over 2 to pi, state what the graph of cosine does. So this is just, do you know the increasing and decreasing stuff that we need to know? So looking at a basic cosine graph, just regular cosine, because they're saying it's just regular cosine. We start at the max, go down and up. The 4 slashes, because the period for this is 2 pi. The 4 slashes are pi over 2, pi. This one is 3 pi over 2, and this one is 2 pi. Okay, so pi over 2, pi, 3 pi over 2, 2 pi. Those are our slashes. So what is happening as theta goes from pi over 2 to pi? So this is pi over 2, this is pi, theta is decreasing. Maybe I should have made it bigger. Theta is decreasing. So they're asking here, what does the graph of sine do between 0 and pi? So let's graph sine. Remember, sine starts at the midline. The 4 slashes are the same 4 slashes as over here. Pi over 2, pi, 3 pi over 2, 2 pi. So they want to know from 0, which is here, to pi, which is here. So sine goes up, and then it goes down. So it increases, then decreases. Good? Same question, but, you know, different interval. So graph of sine, graph a little sine, from pi to 2 pi. So if this is pi, this is 2 pi. For a regular graph of sine. So it's going decreasing and then increasing. So it decreases, then I'm writing in cursive, hopefully you can read it, then increases. Decreases, then increases, that says. Okay, and then the last one's for cosine, so I got to draw my cosine curve. Cosine starts high, ends high, from pi to 2 pi, so the slashes, this is pi, this is 2 pi, so it's always going up, so it's increasing. Horizontal shift of each, this you have to remember is all related to this number if it's in parentheses or not. I just wanted to see if I could do that. So this number here, see how the 2 is in the parentheses? If the 2 is in parentheses, then I have to divide this number by this number. 4 over 2 is 2. Now since it's positive here, you know it's moving to the left. So the answer is left 2. This one again is inside the parentheses, so you divide this number. This is your C, this is your B. So it's always C over B if the B is in parentheses. And in this case it is, so it's pi over 5, and it's negative. So since it's negative, it goes to the right. Okay, this one here, the B is not in the parentheses, so the left and right movement, the horizontal shift is just pi. It's positive, so it moves it to the left. Again here, it's 4 because the b is outside the parentheses, so then it moves negative, which is the right. All right, so now we have to graph tangent. You have to know the basic pieces of the tangent function, and the basic period is always pi, but remember, one cycle goes between negative pi over 2 and positive pi over 2. So that's the initial first cycle. Where is the function undefined? The function is undefined where where it doesn't work. So when you graph it right here at pi over 2, it's undefined, and at, I'm going to call this pi, at 3 pi over 2. Okay, we have to draw these. These are your asymptotes, and they're asking for the equations for them. That's 2 pi. That's, what we usually draw things as. So the equations of the asymptotes are just simply x equals pi over 2 and x equals 3 pi over 2. Those are the two spots. So that's the answer to this one. In interval notation, state the domain. Well, it would be a lot easier if I saw this graph, so I'm going to finish the graph here. I'm just going to scroll over and show you the basics. So if I were to extend this, you have to remember that tangent has another asymptote here at x equals negative pi over 2. That's not in this domain that we need it for, but it does have another asymptote there. So the graph does start down and go up. But you can see we have this negative 3 here. So that means at negative 3, right about here, is where the graph is going to change from concave down. Okay, and that's what the graph usually does. It does a little curve, concave down to concave up. It should be right at that point, but I'm not doing too well. Again, here, it goes from concave down to concave up. Does a little jog, and same deal here. Okay, right in the middle. Nice. So right here is where it should be hitting the graph. Like hitting that, what we could almost call it a midline, that vertical shift down. Okay, so looking at this, I don't need this part. I don't know if I can erase it, but oh, I can. Look at this. I don't need this side over here because that's not actually in the domain of the graph that I want, because I only want it from 0 to 2 pi. So state the intervals in the domain. So it starts at 0. Okay, but 0 is in it because it does continue on the graph. It actually hits a point there to pi over 2. But pi over 2 is an asymptote, so that's not part of the graph, so we need those parentheses. And then we just keep continuing. Pi over 2, 3 pi over 2, and then 3 pi over 2 to 2 pi. So 2 pi, remember this graph would keep going if I needed it to. So that's why this point is actually in the graph. Okay. Is it increasing or decreasing? Well, it's always going up. Remember, we always look from left to right, so this graph is always increasing. And the range is everything. All values of y are met. Okay, so now we want to graph this guy. This is negative tangent plus 1, so we'll do the basic pieces. The basic pieces are the same. This is pi. The function is undefined at the asymptotes, which are pi over 2, 3 pi over 2 in this domain that we're looking at. So right here, and this is going to be pi, and this will be 3 pi over 2, and this will be 2 pi. See, you can use a straight edge. I can't, because then weird things happen. So this is 2 pi. This is pi. This is pi over 2. Again, I'm just writing it down here because it'll get all messed up in there. Okay, this is negative tangent, so it's the flip over the x-axis. And we have to do it at x equals 1. Okay, so if we almost want to call this the midline, It's where the graph changes from concave up in this case, and then it goes to concave down. So tangent, negative tangent is always decreasing. So it should hit at this point. Arrows on the bottom, arrows on the top. Same deal here, but it ends here because that's where the domain that I want ends. State the equations of the asymptotes. Well, that was the x equals pi over 2 and x equals 3 pi over 2. So that's that answer. Interval notation, state the domain. Same as the last one. I shouldn't have drawn that thing. Same as the last one. 0 to pi over 2. Pi over 2 to 3 pi over 2. And 3 pi over 2 to 2 pi. Oh, that should have been down there. I'm not rewriting that. Ooh-wee. Okay, if the graph is increasing or decreasing, the graph is always going down, so it's decreasing. State the range is everything. So not much changes, just change where the graph kind of changes its curviness. Okay, take a second and read this. I'm not going to read it to you. Pause, read, go. All right, now that you're back, hopefully you realize that this is the same problem as like what number was it? Numbers 1 to 8 on the front of this. It's simply now they just have more words. So now you have to figure out the 3 things that are going to help you write the equation. The max, the min, and the period. Can you figure those out? So max is the deepest the water would be. So this is the depth of the water over here. Depth. Excuse me, I'm moving stuff. So this is the depth of the water. And then this one over here, this is your time. So the x-axis is your time. The y-axis is your depth. Whatever. So the max and the min are going to help you find the y values and the a and the d. And the period is going to help you find your interval. Okay, so how deep is the water at the max? Well, at high tide, it's 20 feet. At low tide, it is 4 feet. So we got your max and your min. The period, we do have to, do a little thinking for, but we can do that too. So the minimum is at 4. The maximum is at 20. So we got our max and our min. We know at 4 o'clock, that's our time. That's when we want to start. Number of hours since 4 o'clock, that's our 0 hour is 4 o'clock. p.m. Yeah, I think it's 4 o'clock p.m. Okay, so that's our 0 hour. So we're at high tide at that moment. So since it's starting high, we know this is going to be a cosine model, and it's going to be a positive cosine. Okay, now can we find our period? Well, it says we reach our min at 11 p.m. the same day. Okay, so our min is at 11 p.m. This is 4. So let's say, let's skip 2. So 5, this will be 6, 7, 8, 9, 10. So this is 4, 6, 8, 10. This will be 12. So our minimum is going to be reached at 11 o'clock right there. Not the best grid in the world, but either that or it doesn't fit. Okay, so how long did that take? So between 4 and 11 is 7 hours. So it took 7 hours to go from the max to the min. 7 hours. That is the worst hours ever. So 7 hours to go from the max to the min. So to go back from the min to the max, it's going to take another 7. So at that time, it will be 6 a.m. in the morning. So that's 12. This is 2, 4, 6. We're going to be again at the max. This is our cosine model. That's awesome. So what time is this? This is going to 6 a.m. Okay. So then the total number of time, it took 7 hours to get to the min, from the max to the min, and 7 again. 14 hours is our period. Okay. You just have to figure out how long it took from go to the max, back to the max again, and that's your period. And that would keep going as the tide goes in and out. So from this, we can figure out our A, B, and C. Oh, D, excuse me, we don't need the C. So the A, B, and D. So the A, remember, is the max minus the min divided by 2. So the max minus the min divided by 2 is 8. Our D is our max plus our min divided by 2. So that's 12. And our B, we have to use our period for that. So to find our B, we simply do 2 pi over B equals 14 over 1. Cross multiply, 14b equals 2 pi. Divide by 14. And b is pi over 7 after we reduce. We get our A, B, and our C. Y equals 8 cosine pi over 7x plus 12. So from that, I did sketch a model already. I had to. Couldn't do it without it. Predict the depth of the water at 8 p.m. on June 1st. So 8 p.m. on June 1st. So 8 o'clock, this is 4. This is 6. This is 8. So that's 8 p.m. But the deal of this equation is how many hours since 4. So how many hours since 4? Well, it's been 4 hours. So I need to plug in 4, not 8. Okay? Because we have to go from how many hours since 4 o'clock p.m. So if x equals 4, we just plug that in. And when we do plug that in, we get 8. Y equals 8. So at 8 o'clock p.m., it's 8 feet deep. And as we said, as you can see, here is the 8. It's 8 p.m., so that's 4 hours since. Whatever. The depth of the water is 8 feet. Okay. What time and day will it be at high tide again? That's when we found this one already. It'd be 6 a.m., but it's not 6 a.m. on June 1st anymore. At 12 o'clock p.m., or technically 12 o'clock a.m., it's switched over to June 2nd. So this answer right here would be 6 a.m., June 2nd. Okay. All right, this is the same basic problem. Please try to do this one on your own. Remember, find your max, find your min, find your period, and you've got everything that you need. All right, so the max is 32. The min is 2. The period is, well, it turns out to be 12 hours. So when we do this, I'm just going to scroll down a little. So how many hours since 9 a.m.? So this is 9 a.m. right here. So at 3 p.m., the same day when the tide is out. So that's, so this is 11, 1, and this is 3. So at 3 p.m., the tide is low. So this is approximately 32. This is approximately 2. So here it's at high tide. Here it's at low tide. So 6 hours from then, at 9 o'clock, 5, 7, 9, we're going to have back at high tide again. So it would continue to follow that pattern. So the period is 12, because this is between 9 and 3 is 6. Between 9 a.m. and 9 p.m. is 12 hours. Okay, so there's the sketch. I kind of need to do the sketch in order to do the other stuff. So the max is 32, min is 2, and the period is 12. Simply put those things into your formula. So A is 15, B turns into pi over 6, and D is 17? 17. So it starts high, so it's a cosine curve, so it's y equals 15 cosine pi over 6x plus 17. They want to know what at 8 p.m., so that's around here somewhere. So 8 p.m. is 11 hours. 11 hours since 9 a.m. when we had the low tide, and that's what this equation is all about. So we have to plug in 11. So you plug in x equals 11, and when you do, it'd probably be easier to do in function notation. You get 29.99 approximately. And here, this is 11 o'clock. It's increasing, so the tide is going in. All right, and what time and what day will it be high tide again? Well, we figured that out. It's 9 p.m. on the same day, May 7th. Okay, this one, you just have to take the equation and be able to find the highest and the lowest, the maxes and the mins. So again, we just did this in the beginning. Hopefully you can just do it easier. So remember when we did the max and the min, take your amplitude, the positive, the negative, and add the D. So this one is 120, 126. The min is 6. How long will it take you to go around the Ferris wheel once? So that means how long will it take to make one complete cycle? That's your period. So that's 2 pi over b. B is pi over 10. So remember, that's keep, change to multiplication, and then flip. Put this together, it takes 20 seconds. Okay, and then how high will you be at 15 seconds after the ride begins? Are you going up or down on the Ferris wheel? So you simply have to plug 15 seconds into your equation. So let's scroll down a little. So for D, you simply plug x equals 15 into your equation. And when you do that, you get 66. So you are 66 feet above the ground. Are we going to be going up or going down? Well, I kind of need a graph to do that. So I'm just going to quickly sketch. We have 6 is the min, 126 is the max. This is a Ferris wheel, so you get on at the bottom. It takes 20 seconds to make the full ride. So to go from all the way up and then back down again, it takes 20 seconds. So that's over here is the min and the min. The max is here, right in the middle at 10 seconds. So 15 seconds, you're going to be going down. Okay. And then the last one, same basic question. Make sure you try it yourself. So the max, remember, is 20 plus 25, or 45. The min, it would be negative 20 plus 25, which is 5. How long will it take to make one complete cycle? That's your period, so that's 2 pi over 5. So that's keep, change, flip, and we get 10 seconds. So this particular ride takes 10 seconds. So if we sketch this out a little, This is cosine, so it starts, oops. So this starts at the minimum here because it's a Ferris wheel. It takes 10 seconds to make one full cycle. So at 5, we're going to be back down at the minimum. We're going to be at the maximum. Take 5 seconds to get to the top. This cycle will continue. So remember, at 15 seconds, we will be high. So they're asking for 15 seconds. As you can see, 15 is where we're going to actually reach the max. So you're going to be 45. You could plug it in, but you're going to be at the maximum, and you're not going to be up and down. You are at the top.